Solve the equation. Think, what number squared equals negative 25? There are no real numbers that, when squared, result in negative 25. However, you can simplify the expression using the properties of radicals. Take the square root of both sides, which gives us both positive and negative roots of negative 25. Write negative 25 as a product of 25 and negative 1. We can separate these into two factors using separate radicals. Simplify the square root of 25, which equals 5. The solutions of the equation are not real numbers, but complex numbers. Since the square root of negative 1 is defined as the imaginary unit I, we can write the solutions as 5i and negative 5i. Complex numbers include both the real and imaginary numbers. When combining complex numbers, add the real parts together and then add the imaginary parts. Since we're adding the expressions, we can use the commutative and associative properties to combine like terms. I like to use these lines to separate the terms. 5 and negative 2 are both real constants, so combining them gives us 3. Next, we have imaginary numbers negative 9i and negative I. Combining the coefficients results in negative 10i. Therefore, in simplest form, the sum is 3 minus 10i. Let's find the difference. In this case, we're subtracting a complex number. So to remove the parentheses, we distribute the negative 1 to each term inside the following parentheses. Distributing negative 1 simply changes the sign of each term. Now let's combine the like terms. For the real parts, we have 7 and 4. Adding them together gives us 11. Next, we have the imaginary parts, 9i and negative 5i. Adding these coefficients results in positive 4i. Therefore, in simplest form, the difference is 11 plus 4i. Notice that when you multiply the square root of 3 by itself, you get the square root of 9, which simplifies to 3. Similarly, we can apply this concept to imaginary numbers. The square root of negative 1, when multiplied by itself, results in negative 1. This means that I times I, or I squared, equals negative 1. Let's find the product of these complex numbers. We'll use the distributive property, or the FOIL method, to remove the parentheses. First, 3 times 3 equals 9. Next, 3 times 2i equals 6i. Then negative 2i times 3 equals negative 6i. And finally, negative 2i times 2i equals negative 4i squared. Remember that I squared equals negative 1. So negative 4i squared simplifies to plus 4. Let's combine like terms. For the real parts, we have 9 plus 4, which equals 13. The imaginary parts 6i and negative 6i cancel each other out. Therefore, the final result is 13. Notice that the product is a real number. These are called complex conjugates, where they have equivalent real parts and opposite imaginary parts. Their product is always a real number. We can use complex conjugates to write a denominator with an imaginary number as a real number. To express 10 over 2 minus I in the form of a plus bi, we multiply the top and bottom of the fraction by the complex conjugate, which is 2 plus I. Multiplying the numerator, we get 10 times the expression 2 plus I. For the denominator, we apply the distributive property, or FOIL, which gives us 4 plus 2i minus 2i minus I squared. I squared equals negative 1, and the two imaginary parts cancel each other out, leaving us with 4 minus negative 1, which equals 5. 10 over 5 can be reduced to 2 in the numerator. Distributing 2, we get 4 plus 2i.